I just first want to start off on page 205, okay? I just want to first start off at page 205. And we'll kind of do a quick recap of what we talked about last class. We'll answer homework questions, and then we'll take that quiz over lesson 1 of activity 15. All right, so last class we got familiar with some new terminology. We got a good vernacular of how we're going to describe these sides and angles of quadrilaterals. And the two new terms were being able to identify opposite angles and sides, and then consecutive angles and sides. And we also looked at our diagonals as well. Every single quadrilateral, as long as it's convex, will have two diagonals. We'll always have two diagonals. Now, depending on which special or unique quadrilateral you're talking about, those diagonals may be congruent, they may bisect each other, they may be perpendicular. There's lots of different possibilities that could happen, and so we're going to investigate all of these properties. Same things with these consecutive sides and these opposite sides and angles and so on and so forth. There's unique things, especially things that happen depending on what quadrilateral we're talking about. And so our first quadrilateral was a kite. So we talked about a kite. And we know that from the definition of a kite, we are told that as long as it's a kite, you have two distinct pairs of congruent consecutive sides. That word distinct is extremely important because you got to know that one pair of congruent consecutive sides is different lengths than the other pair of congruent consecutive sides. And so if you were told you have a kite, you know this information. This is by the definition. Because when I ask you to prove things or justify things, you need to be able to tell me where is this coming from? How do you know that that's true? Whether that's as simple as the one pair of opposite angles are congruent, or very complex, like the diagonals are perpendicular. You need to know where this is coming from and how to get there. So this is what we know from the definition of a kite. Okay? It doesn't matter what the kite looks like. This is always going to be true. So I can draw an example of another kite. And if I told you that this quadrilateral ABCD was a kite, then you know with confidence that you can say, okay, well, if you told me it's a kite, then I know that's true by the definition of kite. From there, we proved 5 other properties about kites. One of them was very easy, and we said that one of the diagonals divides this into two congruent triangles. And we said, well, it's this diagonal. It's the diagonal that connects the angles, the opposite angles, that are being formed by the congruent segments. So this angle is being formed by congruent segments. This angle is being formed by congruent segments. Whenever you connect those two opposite angles in a kite, it's always going to divide that kite into two congruent triangles. This is extremely important because this tells us a lot of information about the opposite angles. Because now that I know that these two triangles are congruent by what? Side, side, side. Well, when you claim that triangles are the same exact size and the same exact shape, that means all 6 of the corresponding parts are congruent. I now have that 3 of the corresponding parts are congruent, but now I can confidently say, well, that means this angle is congruent to that angle, this angle is congruent to that angle, and this angle is congruent to that angle. Everything in blue ink is justified by what? CPCTC. This tells me a lot of information because I can now see that one pair of opposite angles, angle E and angle I, are what? They're congruent. That's always going to happen no matter what kite you have. One pair of opposite angles is going to be congruent, and it's the pair of opposite angles that are created by non-congruent segments. So this is not congruent to that segment. So that's the angle that's formed by non-congruent segments. Those will always be congruent. What's happening to the other pair of opposite angles? They're being bisected. So while one pair of opposite angles are congruent, the other pair are being bisected. So this tells us a lot of information just by adding that one diagonal in there and proving that those triangles are congruent by side, side, side. It tells us a lot. Then after that, we started talking about how are these diagonals related and what's happening between them. And so after we discussed this, we said, okay, well, let's add in this other diagonal. And then my first question was, how do you know that they're perpendicular? Well, in order for these two segments, the green and the red, to be perpendicular, that means one of these four angles that's created by the intersection, one of those has to be a right angle. And so that was today's warm-up. So if you can somehow show that these angles are congruent or these angles are congruent, then it's just those 9 steps that was today's warm-up. But you first have to be able to prove that a linear pair consists of 2 congruent angles. And we did that last class. We said that, well, we know that these diagonals are going to intersect at some point. Let's call it just point P. They're going to intersect. Well, we then turned our focus to these 2 triangles here. These 2 triangles. And we said that, well, by the definition in black ink, I know that those 2 segments are congruent. Because these 2 triangles are congruent in CPCTC in blue, we know those angles are congruent. Then what was our third fact about these 2 triangles that are on top of each other? Yes, sir?
Segment KP.
Segment KP. They share segment KP. So by the reflexive property, it's congruent to itself. So do I have enough information to prove that these 2 triangles are congruent?
Yes.
Yes. By what theorem? Side angle side. So now I've proven that these 2 smaller triangles are congruent. Well, right now, all that's marked is, excuse me, is 3 corresponding parts that are congruent. Well, once I've claimed that these 2 triangles are congruent, and I've justified it by a theorem, one of those 5 theorems, I now know all of the other corresponding parts are congruent as well. That means this angle here, angle KPI, and angle KPE, those have to be congruent because of CPCTC. From there, you have 2 congruent angles that form a linear pair. It's those 9 steps that was today's warm-up. From there. And you can prove that those 2 objects are perpendicular. So we did that. What else is happening with this diagonal IE? What's up, Greg?
It's bisected by the other triangle.
It's being bisected. How do you know that?
Because the triangles are congruent, so all the parts are congruent.
We just got done proving this whole triangle is congruent to this whole triangle. So that means that this side, PI and PE, those 2 sides of those 2 triangles, they have to be congruent because the triangles are congruent. So you first show that these segments are congruent by CPCTC. And then it's obvious. It's being bisected. It's being broken up into 2 congruent parts. Okay? So if I ask you on the quiz or a test to prove that the diagonals are perpendicular, or to prove that one diagonal is being bisected, it all starts with adding this diagonal, proving these 2 triangles are congruent by side, 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 using CPCTC to get that information, drawing in the other diagonal, saying that these 2 triangles share this segment, so it's congruent to itself by the reflexive property, proving that these 2 triangles are congruent by side angle side, then using CPCTC. If you're trying to prove that the diagonals are perpendicular, then you need to say that these 2 angles are congruent by CPCTC. If you're trying to prove that the one diagonal is being bisected, then you don't need to talk about the angles, you need to talk about these corresponding sides. But it all starts the same way, with these 2 congruent triangles by side, side, side. Okay, going over these. Number 12 for those of you who have the updated textbook, number 11 for old folks that have the old ones. Now, the first statement says that segment PD is perpendicular to which segment? Segment AC. Okay, now, to justify that, that's very, very long explanation. If it was a proof, it'd be 16 steps long. 16 steps. Because by the definition, you know That's true. Definition of a kite. Then you know that these two triangles are congruent by side, side, side. Then you can say CPCTC, because those two angles are congruent. Then another set of two triangles share that segment. So these two triangles here are congruent by side, angle, side. And then you can say that means this angle would have to be that congruent to that angle by CPCTC. And then today's warm-up. You'd have to say that those measures are equal. Those angles are supplementary. The measures add up to be 180 degrees. Substitute, combine like terms, division, property of equality, definition of right angle, so on and so forth. That's a big, long explanation. Why triangle ABC is congruent to triangle ADC. Why is this the only acceptable way to write those three letters? Gotta match the corresponding parts. Okay, so ADC. Why are these two triangles congruent? Side, side, side. Next one, angle ABC is congruent to angle ADC. Same thing. It's the only acceptable way to write that. How do I know that those two angles are congruent? CPCTC. The corresponding parts of congruent triangles, they are to be congruent. Segment AB is congruent to segment AD. How do I know that segment AB is congruent to segment AD? By the definition of kite. By the definition of a kite. Angle BAC is congruent to angle DAC. How do I know that? CPCTC. You prove that these two triangles are congruent by side, 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 and then CPCTC is how you know that. Sweet. Okay. I'll give you a chance to ask any questions about 7 through 11, except for 9. I didn't even know that one existed. Any questions over 7 through 11? 7 through 11 on the Springboard page 208. Yes, ma'am. Number 7. 7 reads, are the midsegments of an isosceles triangle congruent? Explain. How many midsegments are there in an isosceles triangle? How many midsegments are there in an isosceles triangle? How many? 3. There are 3 midsegments. There's 3 midsegments in every single triangle. What does a midsegment do? Connects midpoints of triangle sides. So it's a mid-segment is a segment that connects midpoints. So I'm just eyeballing it here. These are my legs. Just going to identify this. This is one leg, this is my other leg, my isosceles triangle, and this is my base. I'm not going to capitalize the B because that means something different. Base of my isosceles triangle. So, what do we know to be true about a mid-segment and the that third side? It's parallel and what?
It's
half the size, okay? So, whatever that length is, it's half of this leg. Well, this segment here, it's parallel and half the length of the other leg, isn't that going to be the same length? Yeah. So, the two midsegments that are parallel to the legs of the isosceles triangle, those have to be congruent. What about the third midsegment that's parallel to the base? Does that have to be congruent? No. But could it be? Yes. So if all of those were the same, that would mean this would be an equilateral triangle.